Okay, today we are going to talk about integration by parts. So to begin, we start with the product rule of derivatives. And the product rule of derivatives is this. The derivative of the product of two functions u and v is equal to u times dv by dx plus v times du by dx. Okay, so we can rewrite this thing in short as duv, the differential of uv, is equal to u dv plus v du. You integrate throughout, you get this, and applying the fundamental theorem of calculus, you can say that uv is equal to integral of u dv plus integral of v du. Okay, so you can rewrite this thing as u dv is equal to, take this part there, so you get uv minus v du. This formula is the integration by parts formula. Okay. Alright, let us solve some problems. Suppose we are supposed to find out the integral of the product of x times sine of x dx. Okay, and we rewrite this formula here. Integral of u dv is equal to integral of uv minus integral of v du. Right? So this is a formula never to forget. Very well. So in that formula here you have two choices. You can put this thing as u, x as u, and dv is the remaining terms, sine of x dx. The other choice here is we can put u is equal to sine of x and dv is equal to x dx. Let us see which one works. Suppose we have this. What do we need? We need v. If dv is equal to x dx, v, which is the antiderivative of x, would be x squared over 2 dx. Okay, so let's apply this formula. Integral u dv is equal to u times v, which is x squared over 2 sine of x, minus integral of v times du. If u is sine of x, du is minus times du is cosine of x dx. Very well. So you have v squared, x squared over 2 times cosine of x dx. Okay, now the problem here is the power of x is increasing, so that is not a good news. So we cannot really continue this choice here. So let's go back to the first choice. In the first choice, you have u is equal to this, so du is dx, and v is, okay, the antiderivative of sine is cosine with minus sign. Okay, so let's compute the integral of x times sine of x will be equal to uv, which is this times this, so it is x times minus cosine of x minus integral of v du, which is minus cosine of x times dx. Okay, so this becomes minus x times cosine of x plus integral cosine of x dx. This gives me x times cosine of x. Look, this is easy. Integral of cosine is sine of x dx plus c. So this approach was successful because the power of x did not increase here, it actually reduced. So the lesson to learn here is whenever we have, so lesson to learn here, if you have the integration of an algebraic term any trigonometric term, it is better to take u as the algebraic term. So let us look at an example where you have the integral to be found out is x times the natural log of x dx. Now again you have two choices. One choice is you put u is equal to x and dv is equal to the natural log of x dx, and the second choice is put u is equal to the natural log of x and dv is x times dx. Suppose you do this thing, right? Now here you have du is equal to dx and v is the antiderivative of natural log of x. What do we know about the antiderivative of natural log of x? At this point, not much, right? We will find out what is the antiderivative of natural log of x, but as far as right now, we don't really know, and so we cannot really proceed with this. How about this? U is equal to natural log of x, that's fine. We can take the derivative of natural log of x. So du will be equal to 1 over x times dx. And v is the antiderivative of x squared over 2. Okay, let us solve this thing using this approach. I will be equal to uv minus integral of v du, right? What is u? U is natural log of x, v is x squared by 2. So you get x squared over 2 times natural log of x minus integral of v times du, which is, this is x squared over 2 times 1 over x dx, right? Which is nice because the power of the term x is going to reduce. So here you have x squared over 2 times the natural log of x minus half comes out integral of x dx. Okay, and we know the integral of x is x squared over 2. So you have the final answer is x squared over 2 natural log of x minus 1 over 2 x squared plus the constant of integration. Okay, so the question is, what is the antiderivative or the integral of natural log of x? So here we observe that there is an invisible 1 sitting here, and you have a multiplication of 1 is x to the power of 0, so it is an algebraic function, and here you have a logarithmic function. So the lesson number 2 says that put u is equal to natural log of x and u is dv is everything else. So you have dv is equal to dx. So you have u is equal to natural log of x, du becomes 1 over x dx, v, this is 1, so it becomes x, the antiderivative of 1. So you have I is equal to, okay, so the integration by part formula is uv minus integral of v du. It is u times v, in this case x times natural log of x, minus integral of v times du, which is x times 1 over x times dx, which is nice because this gets cancelled and I get x times natural log of x minus integral of 1 dx, and this thing is x times natural log of x minus. Suppose you have a problem where you have multiplication of algebraic function and exponential, then what to do? So something like this. Integral of x times e to the power of x dx. Now again you have two choices. Either you can say that u is equal to x dv equals e to the power of x dx, or the next choice is u is equal to e to the power of x and dv is equal to x times dx. Again observe, if you follow this path, dv is equal to x dx, v becomes x squared over 2, and then ultimately you will end up multiplying that with du, which is e to the power x dx. So remember, our formula is integral of u dv is equal to uv minus integral of v du, right? So v times du gives you x squared over 2 times e to the power x, and the power of x is increasing, and we cannot proceed further. So we follow this path, okay? And here we have du is equal to dx, and v is equal to e to the power x. Okay, so you have the integral to be equal to u times v, which is x e to the power x, minus integral of v times du, which is e to the power x dx. Now this is simple enough. So you have x e to the power x minus e to the power x plus the constant of integration. Okay, so again the lesson to learn here is lesson 3 is if you have the integral of algebraic and exponential, then you should take u as the algebraic function, right? Because if you take the derivative of an algebraic function, it reduces, and exponential doesn't change, right? E to the power x remains e to the power x.